Hey guys, I'm Evan. Welcome to Country View Solar. So last time we looked at the 12K PV, it was only hooked up with a bunch of loads and the batteries. It was completely off-grid. We did some off-grid testing. And today, or since then, I've actually got a grid connection going to it. We also have 2 solar arrays going to it with 7,360 watts of solar. The only thing that is not hooked up to this right now is a generator backup. And a lot of people don't get those hooked up anyway. So it's pretty well completely wired up. What we're going to do today is I'm going to try to get it hooked up to zero the meter. We're also going to do Sellback power to the power company. And then we'll also do some more testing now that we have it completely wired up. We'll do some more testing on the system. And right now I'm just charging up the batteries. If I get closer, you can probably hear the fans running. So we'll do a little test here. We'll see how loud it is. This is probably as loud as it's going to get. So as we look in the front here, you can see that we are charging the batteries with 142 amps. And then here at the front of the enclosure, hopefully you can see that. So you can see with the fans going, it's running between 55 and 60 decibels right here in front of the enclosure. And this is an outside unit. It's a sealed unit. I believe the fans are just going through a bunch of heat sinks on the back to help cool the internals. Let's just take a quick look at the inside and we'll show that everything's wired up. So as we look inside the 12K PV, you can see we do have a grid connection coming in, and then we have our loads going out, no generator hooked up, and then we've got our battery connected. And as we look at the other side, you can see this is the battery communication cable, and then we've got a solar array on PV1 input, and we have a solar array on PV2 input. So right now, the way this system is configured, its number one priority is to power this load panel. That's the first priority. Second priority is it's going to charge the batteries. And if neither one of those need power, or if it has extra power, then it will take the extra power and it will send it backwards toward the grid. And depending on how you're set up, I have another breaker panel further up, so that power going backwards could power other loads that I have, but it also could be sold back to the grid, to the power company. But what I want to do is I actually want to monitor the incoming power from the grid so that I can backfeed and zero that meter so that I don't have an electric bill. Now to do that, the 12K PV comes with a set of CTs, and that's a current transformer. It's also known, some people call it a current transmitter, but that is what these are right here. And these are little transformers that clamp over the incoming wire from the power company. So you got your 2 main wires coming in. This, you put it around the wire, you clip it shut, and then it can read the amperage on that wire. So you got one for line 1 and one for line 2. And that's going to allow the 12K PV to see the incoming power from the grid. And then anytime it sees a power use, it can backfeed and try to power the device instead of the grid powering it, thus zeroing your meter. So once we get the CTs set up, priority number 1 will be, of course, the load panel here, but it will also be the load panel that it's monitoring backwards. So its priority is to try to power these loads plus the loads upstream from the 12K PV. Second priority, of course, is going to be to recharge your battery bank. And then the third priority, if there's still extra power after all of that, then it sends it backwards to sell it back to the power company. And you actually have a true reading of what's going back to the power company, and you have a true reading of what's coming in from the power company when you install these CTs. So the CTs that come with this, they have a fairly long cable. Set them down over here, and you can see this cable, I didn't measure it, but it's probably around 12 to 15 feet long. And it's meant, if this is within, 10 feet of your meter, you can just run it straight over there and clamp it onto your incoming power. Now the problem I have is that my incoming power is on that side of the workshop. So we're gonna have to extend this. And this connects to the 12K PV just using a regular RJ45. This is an Ethernet, like a common Ethernet connector. So what we're going to do is we're going to run a Cat5 cable from the 12K PV up to my incoming breaker panel so that we can make this cable longer, and we'll get this all hooked up. So I'm just going to run a piece of conduit out the ceiling to run this Ethernet cable. So this here is the main breaker panel coming in from the grid, and from here it goes out to power the workshop, to power my house, everything. So if I can zero the meter here, you know, this is the first point of incoming power. So this is where the CTs really need to go. So I've got the Ethernet cable coming into the bottom of the panel here. I've just got a cord grip or a CGB fitting down here to hold it, and I'm just going to put a regular Ethernet connector on it. So I'm just going to be using this Klein Ethernet tool, and it does have like the little color code pattern that you need to make sure you have your Ethernet cable all lined out in that pattern before you crimp it onto one of these little RJ45 connectors. And I do suggest you get the pass-through connectors so you can slide those wires in and they will slide all the way through, where you can then look at it a second time and make sure that you do have them in the correct order before you crimp it. I think it's a lot easier to verify that with these pass-through connectors. So inside this Ethernet cable you have 4 twisted pairs of 4 different colors. So we just need to untwist those and try to straighten them out. So I think I've got the wires in the right order now. So I think I'll just go ahead. I'm just going to clip the end of these real quick. Now they're all the same length. Now I'm going to take my connector and I'm going to try to slide these in to the connector, and then they should pass like all the way through, like so. Can you see that? How it passed through? All right, I got them all out now, so now I just need to re-verify they're in the correct order. And after I've verified that this is the correct order, I'll put it in here and I'll crimp it. And that will also cut off the lead sticking out of the end. So it's nice and trim, ready to work, ready to go. So now it's time to install the CTs and our main breaker panel on the incoming power wires from the grid. And this is going to read the power we're pulling in from the grid, but it also read the power that we're selling back. And so these are directional, so that it reads correctly. And there's a couple labels on here. So this one has a wraparound label. It says L1. This one says L2. So that tells you which wire to put it on. And then when we look at the other side, it has one side, it says grid. You probably won't see that, but it says grid right there. And we need to make sure that this side is on the grid side. So this grid would face down or face toward where the incoming wires come from. So when you look inside the panel, the black wire, that's line 1, and the one I have taped red, that is line 2. So we'll find the correct one. This is line 1. grid is on this bottom side, so we're going to make sure the grid is facing the grid side. And the thing that says, the other side says PCS, we're going to point that up toward our breaker panel. Same thing on line 2, grid side. It's going to go down toward the incoming power. And then PCS will be pointed toward the breaker panel. And make sure they lock shut. Get them. So the CTs will work fine just like this, but I like to throw a little zip tie around them and help hold them in place. And then there's the other one. So I just kind of like them nice and neat like that. Don't have to do that. Now I've got 12 feet of extra Ethernet cable here. I'm just going to wrap this up and tuck it in the corner of this panel. So now I'll take the Cat 5 connector from the CTs. I'm just going to put it in this coupler. And then I'll take the other side that we made up and we'll connect it to the other side. And there we go. We just put the panel cover back on and this part's done. And now our cable from our CTs, it just plugs in right next to the battery communication. And we should be able to just program it now. So I think I've got all the settings right in the 12K PV now. I did end up, so you can do the settings 3 different ways. So you can go through the settings on the screen here. You can use a mobile app on your phone and you can go to the settings screen and then you can open up each one of these settings and set it that way. Or you can go to the web browser and log into the EG4 monitor that way. And I think that the web browser is the best way for beginners to do it because on each one of the settings there's a little blue question mark. You can click it. It will explain exactly what that setting is. So it has a lot more explanation when you go in and set it up the first time. So that's what I ended up doing. I had to go into the browser and set it up that way. So it appears that the CTs are reading fine and we are exporting power now. I have this screen. I'll put this screen up on so you can see it. So 1,741 watts worth of solar coming in. We're consuming 1,132 and we are exporting 578 somewhere in there. So we're making all the power we need and we're exporting back to the power company. So seems to be working just fine. So now that we've got this all set up for the first time, grid power, solar power, everything, I figured we'd go ahead and do some more testing. So let's just do a quick grid down test and see how it reacts. So I'll flip off the grid power. There you go, almost seamless. I don't know if the camera picked it up or not. There's just a slight little flicker of the lights. And we're now on battery backup. So that checked out good. I'm going to turn the power back on. There's a setting inside of here. It's a default setting 300 seconds before it switches back to the grid. I changed that to 120. So it should take 2 minutes to flip back. All right, just clicked. We went back to grid. I've got some heaters I've got here plugged in. We're going to do some load testing and see if we can kick it up here. Set that on 70. I can smell these heaters burning off the dust. They're warming up. So I think these 2 heaters here are going to be somewhere around 10,000 watts, 9 to 10,000 watts, more than the 8,000 watts of the 12K PV. So if I turn off the grid, we should overload. Still running. Still running. Yep, we are still running 10,000 watts of output. This shouldn't be able to handle it very long. It's 8,000 watts max, but we're doing 10,807 watts. We'll do a timer here. We'll find out how long this will run. There she just kicked off. So everything's reset now, and it ran 10,800 watts for 51 seconds. That's how long it ran it. And it's only supposed to be continuous 8,000 watts when it's off grid. And it does have a little bit of surge capacity there. It was able to handle an extra, what is that? Like an extra 20% for almost a minute. So that was pretty good. So since I didn't show like hooking up the grid connection, the solar panel wiring, I decided to go over that real quick. So when you open up this door, there's a few things like the manual I got varied from the newer manual. And then if you look inside this door right here, there's a little chart. So this lays out the specs for all your connections. So like the battery, it's going to be pulling at least 170 to 200 amps. And the cable, you're going to need 2 to 3 aught cable for that. It tells you the torque specs in metric and the torque specs in inch pounds. And it has this for the battery, the generator, the load, your grid connection, your ground, and your neutrals. So what varied from my manual and this door and the new manual is like the grid connection says 125 amps, 1 to 2 gauge wire, and then it shows your torque specs. So the manual that came with this said the grid connection should be number 6 or number 4 wire, and the new manual, when you download it, I think says number 4 wire, and they're meaning copper wire. And of course this one was saying 1 to 2 gauge, so you see the difference there. And you definitely want to, when you get something like this, you want to download the newest manual off of EG4's website and see what it says to connect it with. Now this inverter only passes through 80 amps, so you only need an 80 amp connection to be able to come into here. And if you don't have any solar or batteries, that 80 amps will just pass right through to the load. It'll keep powering your stuff from the grid if you don't have any solar. So I did end up hooking up 2 solar panel arrays to the system that used to be on the EP Cube. I actually had a fatal error on my EP Cube. I had 2 of my solar inputs go bad. And I'm going to be replacing that here pretty soon. But I ended up just bringing that solar over to here. And remember, my rooftop solar has the rapid shutdown system on it. It has TEGO rapid shutdown modules, but they are compatible with the 12K PV. So to the left of the solar inputs, there's actually a rapid shutdown module in here. It's blinking green right there. And that is actually an AP Smart rapid shutdown transmitter. So AP Smart makes rapid shutdown transmitters and modules, and so does TEGO, and they both speak what they call PLC communication or whatever. So they both speak like the same language. They're supposed to be compatible with each other. So my TEGO modules are working with this AP Smart transmitter that is inside of here. So I've got my amp meter set up on here now, and we're going to do a surge test. So I tested the 5 horsepower air compressor before, and this would not start it off grid, but we did get about 90 amps of surge. And we were just running this one battery down here. And a lot of people thought that it should have been higher. And they thought maybe it would go higher if I have more batteries. So now I do have more batteries. So we'll see what the surge is with it on the grid. And then we'll do off grid, and we'll see what the surge went up, got higher with the bigger battery bank. So I just got to run an extension cord out to the compressor. Oh, man, we dropped everything. Did you see that? We dropped it all. So we ended up with a 103 amp surge. All right, we're going to try it again with grid power is on. Ah! All right, it started it this time, 107 amps. I'm going to turn the grid power off. Okay. Well, it tried. It tried. Didn't quite get it. 102 amps. So 102.5 amps. So still doesn't start the air compressor and off grid. So 102 amps is, I believe, higher than last time. So we do have 3 server rack batteries over here. We probably got at least 400 amps of battery power compared to the I think 200 amps that we had before. So it may have increased it just a little bit, but needless to say, a 5 horsepower air compressor is way too big for a 8,000 watt inverter. So I haven't tested the rapid shutdown on this, and there's actually a built-in rapid shutdown button on the side of here. And when I hit this, it should shut off the solar panels. It should turn off the output from the inverter, and it should throw the breakers. It'll actually open the breakers on the EG4 batteries. It should do all of those things. So here we go. Took a little bit, that's for sure. So when you push the rapid shutdown button in, it stays pushed in and it glows red. So the inverter seems to be powered down. The breaker is thrown on here. And then the breaker is off here, and it is off on the other EG4 battery as well. All right, so to recover from the rapid shutdown, the batteries will not let you turn the breaker right back on. You actually have to turn them completely off. You have to turn off the battery management system on each one. Then you can turn the battery back on, and then you can boot up all your batteries and you can recover. So if you ever do the rapid shutdown, it's not an instantaneous recovery. It can't recover on its own. You do have to intervene. So the installation of the 12K PV, I think everything's done now. So it's just time to just let it work and see how it performs. This is going to take over exporting power to the power company. My EP Cube system that I have, it used to do that, and I have turned off the export on that system, and I took 2 of the solar arrays off of that system, and that's what's on here. And this is strictly going to be the one inverter that interacts with the power grid. And we'll test this over time and we will see how it does. And if you guys have any questions on this system, post them down in the comments down below. I'll try to answer them. If you guys have something you want to test or you have a really good question, I may end up making a video about it. So I think that's going to be it for this video, guys. So thanks for watching, and then I'll see you in the next one.